is Connor Ito, and as a member of Eutrophication A, I'm here to discuss our wicked problem. Eutrophication of the Gulf of Mexico is a serious predicament that occurs when river or ocean systems are overloaded with nutrients above the natural level. An excess of phosphorus and nitrogen will cause algae to increase and in time will strip the water of its oxygen. This will create a dead zone, areas where life cannot live. And in the northern Gulf, um, eutrophication has created a massive phytoplankton bloom on top of the surface of the water, which will actually prevent any plants underneath from photosynthesizing. They'll die, and in time, that algae on top will actually die as well and go to the bottom of the water column, where it disrupts the water column and depletes the oxygen and essentially will destroy uh, the cycle of life within the water. Bacteria will actually eat the plant matter and will continue to produce more nutrients. And with this unlimited resource of nutrients, they will deplete all the oxygen and basically expand the dead zone. Now, the Mississippi River Basin is responsible for most of the rivers that run into the Gulf of Mexico. This basin stretches all the way west from Idaho to east in Massachusetts, and alongside all these rivers are many agricultural farms that have contributed greatly to the toxic runoff. Um, Supported by the Green Revolution in the 1930s, we have increased the amount of pesticides and fertilizer used in agricultural farming to produce more food. Nitrogen and phosphorus are naturally occurring chemicals that contribute to organic growth and are continually recycled through a complex cycle of organisms, plants, and environment. And because of this overabundance and overuse of the pesticides, both the nitrogen and phosphorus cycle are out of balance. Um, Now we've only begun to understand this wicked problem. Thankfully, there's a lot of scientific data and common knowledge about this, and we can use that to hopefully create a solution. We can inform farmers of more sustainable ways of farming, such as hydroponics and biodiverse farming. And working together and sharing knowledge is crucial for a brighter future without more dead zones in our oceans. Thank you.
Hey guys, my name is Alex, and I will be discussing the current status of eutrophication in the Gulf of Mexico, as well as our vision for where we want to eventually end up. So, hypoxia in the Gulf of Mexico has increased in size to around 7,722 square miles, which, to put it into perspective, is about the size of New Jersey. I know, whoa, right? That's large. Well, why is this happening? According to the USDA, 80.9 million acres of corn alone was planted in the United States during the year of 2015. Statistically, on average, 97% of the land is covered in fertilizer. So because the crop can't absorb 100% of the nutrients, a lot of them end up in the water runoff from the farms. This problem, coupled with the destruction of the wetlands, is where it really starts to escalate. Without the wetlands as a buffer, the runoff goes right into the river, eventually reaching its final destination, the Gulf of Mexico. The amount of nitrogen alone getting to the Gulf has increased by 300% since the 1950s. This is heavily impacting the Gulf's environmental and economic sustainability. The people who are part of the fishing industry there need the fish for their livelihoods. With benthic fish, redfish, and several different types of trout washing up onto shore, and decadal decrease in brown ship landings, this is a pretty bleak future for the people of the Gulf. With the amount of fish already decreasing, it is equally as important to increase the limit of which is allowed to be fished per season. This accompanied with alternative farming methods like hydroponics, alternative fertilizers, and water runoff prevention, the eutrophication can be halted. Our vision for the future states, both the farmers and the fisheries values need to include valuing the protection and the restoration of the environment so that they can continue to profit in the future. They need to believe that there's a greater responsibility to the future of their livelihoods and communities. We'd like to halt and even reduce the current eutrophication of the Gulf and make it a livable and lively place. Restoring the oxygen levels will bring back the coral reefs, the fish, and the organisms that all call the Gulf home.
Hi, my name is Sam, and I'm with Eutrophication A, also known as Group Class, and I want to talk about our plan to measure our success along the way on to our vision. So overall, we want to reduce the nutrients entering into the watershed of the Mississippi and Atchafalaya River basins. So we've given it a time frame of 20 years, and during the pre-developmental stage, we're looking at a 10% reduction across the board. We believe this is a very achievable goal. So this means by 2020, we're looking at 1.26 million metric tons of nitrogen still entering the watersheds, along with 135,000 metric tons of phosphorus entering the watersheds. This is based on data collected in 2009 by the Environmental Protection Agency, as appears in these slides here. And so this would give farmers a chance to make the cuts that they need to make if they're just going to cut out the phosphorus and nitrogen in their farming practices and their fertilizer, or if they want to alter their landscaping to bring back in the wetlands that have disappeared, creating those barriers that prevent the runoff from getting into the rivers and all the way down into the Gulf of Mexico. And then also maybe they'll come up with innovative strategies we haven't even considered yet. So after the pre-developmental stage, we're looking at our targets increasing exponentially so as to have a lasting impact. So during this portion, we would like to see the technology that was used during the pre-developmental stages that was super successful become more widespread. And numerically, what we're thinking is by 2030, reducing everything by 50% of the 2020 goals. So this would mean 630,000 metric tons of nitrogen and 67,500 metric tons of phosphorus entering the watersheds and making its way to the Gulf of Mexico. And finally, looking at 2035, entering a stabilization with 500,000 metric tons of nitrogen and 50,000 tons of phosphorus, and no more than that, entering the water basins of the Gulf of Mexico. If we can meet these indicators, we're thinking we can reduce the hypoxic zone of the Gulf of Mexico from 15,000 square kilometers to 5,000 square kilometers.
To discuss our approach to meeting our vision. Our approach to meeting our vision will be to heavily engage multiple stakeholders in strategically composed task forces along the Mississippi River Basin and coastal communities. We will work with local governments to create a mandatory participation in eutrophication reduction task forces. These task forces will be composed of members of a local governing body, such as the Division of Wildlife and Natural Resources, or the EPA, farmers, fishermen, and members of the community. Farms and fisheries will be required to appoint a task force representative from their organization, much like OSHA regulations require safety officers in the workplace. It will be the job of the scientists from the governing bodies to create educational material and training for task force members relevant to their local government policies and regional needs. Semi-annual training of all farming and fishery staff will be required, with individual online tests administered at the end of each training session. Through this system, farmers can learn about tax incentives for restoring wetlands and sustainable farming techniques, and fishermen can learn about lowered limits and more sustainable fishing practices. The community members in the task force will be voluntary and will learn what they can do as individuals to promote sustainable home gardening, pet and home waste disposal, and be trained in the door-to-door canvassing techniques recently published in the April 2016 issue of Science magazine to further educate their communities. Scientists, alongside community volunteers, will monitor our progress annually by measuring the density of the oyster reef, measuring nitrogen and phosphorus in the water, and the square footage of the dead zone. A coastal community monitoring website will be created for nature enthusiasts to record the marine biodiversity they observe in their communities, much like the Cornell Lab has done with their citizen scientists reporting bird counts. From the training feedback, measurements of the reef and dead zone size, measurements of the nitrogen and phosphorus in the water, and the biodiversity data from the communities, we will be able to adjust our focus when needed. In conclusion, we believe the keys to success are education and a sense of personal responsibility for fixing the problem of eutrophication through stakeholder involvement, in addition to incentivizing the farmers and fisheries to participate through tax incentives, as well as creating a mandatory participation and education.